Alright, so this is my speech comparison demo. A few updates from last time, but well, the demo I'm going to do now is say 4 names. I'm going to put Adrian, Nicole, Sarah, Nacho into my database, and then I'm going to say Nicole and see the comparison, the correlation between what I just said, Nicole, and the names in the database. So let's see. All right, how many names will you be putting into the database? 4. So I'm going to start recording the names. Adrian, Nicole, Sarah, Nacho, Nicole. All right, it's doing its magic. And you shall see here the waveforms with respect to time. Just give it a second. All right, so as you can see, the name to be compared here is one I said, Nicole. First one here is Adrian, second one's Nicole, third one's Sarah, fourth one's Nacho. So all of these were recording from 0 seconds to 1.5 seconds. As you can see, the name to be compared, this one that I said, Nicole, the second time, its waveform looks closest to the second slot here, which is Nicole again. So let's see what we were given. So these correspond to the slots 1, 2, 3, and 4. 1, 2, 3, 4. So this is the correlation of the name I wanted to compare, Nicole, with Adrian. So highest peak here, it's like there's a 38% chance that it is that this first slot, Adrian, is what I said, Nicole. So that's not correct. This one, the highest peak amongst these 4 plots, is this one, 76%, as you can see, and this one is Nicole. So that's why there's a higher correlation here. The higher the peak, the higher the correlation. That's pretty much what it means. And there's a 76% chance that this is Nicole. So this was the comparison in the time domain, comparing this wave right here with respect to time to the wave here with respect to time. So now let's see what happens when we compare in the frequency domain, so with respect to frequency. So this is the 4 names in the database, the frequencies, the Fourier transforms of all names in the database, 1, 2, 3, 4, and the one I said at the end. So as you can see, this wave, or not really wave, the FFT here looks more like this second one, which was Nicole, than all the other ones. So I'm also comparing these, the signal in the frequency domain. So let's see how they match up. Right. Is it this one? Yeah, it's this one. All right, so where's the other one? Okay, so as you can see, the higher the peak, the higher the correlation in the frequency domain. So this one was Adrian, this one was, Adrian compared with Nicole, Nicole compared with Nicole, Sarah compared with Nicole, and Nacho compared with Nicole. As you can see, the peaks here are higher, and they're higher because we're comparing in the frequency domain, which means that the way I speak is pretty, there are harmonics or formants that that make up my voice and makes it unique. And as you can see there, despite I did say different words here, there are some frequencies amongst all of these plots that remain somewhat constant. So you see the fundamental here, that's, I don't know, 130. You can see them throughout all of the plots. So because I'm looking in the frequency domain, the correlation is higher because it sees that, oh wow, the frequencies coming out of Luis's mouth right now is very similar to the frequencies that are prominent in the database, which is Luis's voice too. And this is again, I mean, where voice biometrics start, but that's not the point right now. So because there were certain frequencies in the syllables that I accentuated when I said Nicole, there's a higher correlation here at the second slot, which is Nicole, the word I said Nicole. There's a 95%. Actually, let me just use the tool here. There is a 75% in the frequency domain here that Nicole matches with Adrian. There's a 95% chance that Nicole matches with Nicole in the frequency domain here. 5. Now here, there's a 77% chance, I'm looking at the number here, there's a 77% chance that Sarah matches Nicole in the frequency domain. And there's a 78% chance that Nacho matches with the way I said Nicole in the frequency domain. So as you can see, in the frequency domain, I have been able to make a match. So I said Nicole, and in the frequency domain, we compared the way I said Nicole with all the names in the database, and the highest one was indeed Nicole. Nicole compared with Nicole gave a positive, a 95% chance in the frequency domain. And in the time domain, where is it? In the time domain, there was a 76% chance. So the way I'm trying to make this speech comparison algorithm work is make sure that above a certain threshold, I guess maybe above a 70% chance, if something gives me a positive above 70%, this is 76, so it's above 70%, let's say, let's consider this. However, there might be other words like Nick and Mick that might look similar in the frequency domain. I mean, in the time domain, it might give me a positive, maybe a 77% chance that they're the same, or an 85% chance that they're the same. But that's comparing in the making the comparison in the time domain. However, that is why I'm also relying on the frequency domain to make sure that I am not, I mean, this would be a second layer of, I guess, verification, that Mick matches with Mick instead of Mick matching with Nick, you know? So I'm using the comparison in the frequency domain as a second layer of verification, I guess, of security, to make sure that the match we have made in the time domain is the same, and the percentage of it being the same one is as great as big as in the frequency domain. So yeah, that concludes my demo. However, there are some tweaks I want to make, and I will get to that in the meeting.